to my YouTube channel, DotNet-Dev-Journey with Jacob. And today we are going to be looking at a very interesting topic together. I've completed the phase one of my learning journey, and today I'm going to be starting the phase two of my learning journey. The phase one was learning the principles, the basics of C# and object-oriented programming, learning the basic principles and some other extras like the dependency injection, the solid design principle, logging, and the likes. But in this phase, I am moving on to building a web API. So the second phase is dealing majorly with ASP.NET Core, building web API with ASP.NET Core. But before we delve into this, there are some important points we need to speak about. And one of the things we are going to be looking at or discussing is HTTP. I'm going to be listing them as we get along. And I also want to make this video as short as possible. So what does web mean, or how does the web work? Whenever you open your computer, you enter a URL address or your mobile phone, what really happens? So what happens is this. Basically, we have a client, which could either be your mobile device, your PC, your tablet, your iPad, name it. So, and the next thing is from the client, a request is sent. So, once a request is sent, obviously, we should know that there will be a receiver on the other end, because the client is the sender here. In this case, the sender sends a message, which is a request, and the request gets to the receiver, which is the server. That's the receiver. And once that is done, then a response is sent back. So the client sends a request to the server, then the server sends back a response to the client. So, and we are still going to be talking, or I'm going to be explaining what request is, what response is. So the client now is the front end, the device that is sending the request, which could either be a mobile phone, a PC, and so on and so forth. And the server, we all know what a server is, so I wouldn't dwell much on that. But internally, ASP.NET makes use of Kestrel um, server. That's the inbuilt server for ASP.NET Core. So, having said this, how is the request sent? The request is sent like via an HTTP um, protocol, and that brings us to what HTTP mean. So what HTTP simply means hypertext transfer protocol, which is like a contract, a rule that guides communication between two or more computers or machines, as you might or as you may want to call it. So it's a contract that guides or a rule that guides how two or more computers communicate together. And HTTP makes use of action words like verbs. They are HTTP methods through which request is being sent. And this method includes uh, excuse me. So this method includes we have these verbs, that is action words, get, posts. I'm going to explain all this. Post, we have put, we have delete, we have hatch, which is not very common. So these are synonymous to the normal CRUD operation that we do. So get is to, like inquiry, to get information from the server. Post is you creating an object or a new resource in the server. Then put is you modifying, updating, or changing the entire resource state in the server or an entire record in the server. Delete simply means you're removing a particular record or a resource state, deleting it completely from the server. Then patch is a partial update or partial change of the record in a server, like a partial change. For instance, let's say you have um, a customer entity. So you could probably change the email of that customer, just the email. So that's patch, updating or changing, you know, um, parts of the field of an entire record. Let me put it that way. So if that will help us understand it better. And having said this, there is also another thing to look at. So we'll be looking at something called an idempotency or idempotency, as you may want to call it. So what does idempotency mean? An operation is referred to as idempotent if performing that operation multiple times will result in the same final state as performing the operation once. I repeat again, if performing a particular operation will result in the same final state as performing the operation just once, then it means the operation is idempotent. And there are some of these HTTP methods that we can see is idempotent. For instance, get get is idempotent. So let's say, for instance, you may want to ask why is get idempotent. For instance, if we want to get the balance, the last project I designed was around it was a banking system. So let's say I want to get a balance of a particular account. If the balance, for instance, is £1,000 and you perform the operation over and over, like getting the same balance, you keep getting £1,000. That wouldn't change. So performing this get operation multiple times will give you the exact same result, which is going to be £1,000. And if you perform the operation once, you still get £1,000. So get is an idempotent method or operation. So now another one is the puts. So put simply means, I said changing the entire um, state of a resource in the server. So let's assume that I am a customer with customer ID 204 and you're trying to change or modify the entire state of that customer 204. So if you change or modify that state, like you're modifying it with the same record, with the same data, you also keep getting the same result as when you update the customer 204 with the same data once. So let's say now in we have a wallet and we have a wallet ID and a balance. That's just the state of that wallet. And you want to update that wallet. You want to update per se, let's say the entire state of the wallet. We are going to be picking the wallet ID to update that wallet. So let's say the wallet ID is equals to 204 for instance, and the balance we want to update it to balance is equals to 500. So if we are updating this wallet ID 204 to a balance of 500, if we perform this operation more than once, we'll get the same final state as performing it once. So we can say puts is idempotent. Then another one is the delete. Delete is also idempotent because if you delete a particular record, it erases it entirely from the server. So if you delete it the first time, you will get a response which will be probably 200, that's success. If you run it again the second time, you will still get the same final state because it's removing that same record. It's not going to remove two records. It's going to remove that exact same record from the DB from the server. And since that record has been removed the first time, if you run it again the second time, the record is no more there. So it still leaves the system in the same. The final result is still the same. So running it once, running it twice gives you the same final state. So delete is idempotent. Post is not idempotent because whenever you post, you are creating a new resource state, a new resource. Let me put it like that. You're creating a new entity, a new resource. So if you keep posting, you keep creating new resource every time you use the post method. So post is not idempotent because you keep getting new resource created. Then the patch is not fully idempotent. It's partially idempotent as well. So we cannot classify patch as full idempotent operation. I think I need to run fast now. So having said that, there is also something we call response code, as we want to put it. So these are responses that, don't forget I said the client sends request to the server sends back a response. So their response code, which starts from um, 200, we use 2xs to about 5xx. So here we have the 200 equals success. Then we have 201, which equals, I think, created. So that's if you want to create a new resource. Then we have 400, which is, I think, bad requests. It's that bad request. Okay, yeah, bad requests. It is important to know all these response so that we can use them effectively and efficiently. We have 401 that should be unauthorized, unauthorized. Then we have 403, 403. Is it 401 or 402? Okay, I think it's 401. I'm actually not sure now. Not very sure now. Uh, 403. What's 403? Uh, what's that? Ah, bad request, unauthorized. Okay, let me move to 404. Can't remember 403 now. 404. That's not found. Then we have 500. That's server error. Server error unauthorized. Uh, mm, I'm trying to get this 403. I don't know why. I'm just it's kind of skipping my mind right now. Why is that? Oh, okay, I think I'm going to remember as we get along. Let's just continue. I should be able to remember as we get along with it. So, having said that, the next thing we need to speak about, okay, this is forbidden, yeah, forbidden, 401 unauthorized, 403 forbidden, 404 not found. Yes, I'm correct. So, now let's move ahead. There are some things I'm going to be, okay, yes, I think there is need to talk about middleware. These are some of the things that ASP.NET has opened my understanding to. Middleware. What are middleware? Middleware, literally can be referred to as series of components that make up the pipeline that processes the requests and response in ASP.NET. So it handles the requests and the response. So it's like a chain of operation, chain of components that forms a pipeline. So it can, how do I put it now? It can modify a request. It can also short circuit a request and then call the next operation in the pipeline. So for a middleware, it's something like this. Don't forget I said pipeline. We could have middleware 1, middleware 2, middleware, no, sorry, middleware 3, and so on and so forth. So it's like a pipeline like that you know modifies the request, could also short circuit the request. Then after processing the request, it calls um, for the next operation in the pipeline. So this is middleware 1. It calls the next middleware in the pipeline. Once this successfully carries out the operation on the HTTP request, it calls for the next middleware until it gets to the bottom, the one at the bottom part. So if this is the one at the bottom part, it gets here, then the flow of control moves upward again until the initial middleware to also pass on the response until it finally moves out of the middleware to the client. So let's say the request is coming in from middleware 1, works on it, calls the next middleware, works on it, calls the next middleware and to the server. Then this also, the flow of control also passes up the pipeline from the bottom middleware down to the second, down to the first, and back to the client. So that's how it works, and it has to be um, in an orderly manner. Order is very, very critical in registering um, in the middleware order. Order is very, very critical in this pipeline. If, for instance, if authorization comes before, if authentication comes before authorization, there's going to be an issue. If authorization comes before map controller, there's going to be an issue. So it has to be in an orderly, manner for the system to work efficiently. Having said that, there are other things I'm going to be explaining, but first, let's quickly come here and let's open a web API. So we are using a web API, and here ASP.NET Core Web API, as you can see, because we are building a web API. So now, although I would have loved to continue with the console project I've built before, which is the .NET console banking system, I could have just continued and transform that into a web API project, which I'm still going to do, of course, but for now, I'm going to be working on a project, which is a wallet, um, a a wallet kind of project. It's also based on, financial operation, a financial application as well. Or I could do something more like a transaction or fraud detection, you know, stuff because I've worked in the banking industry before, in the financial industry. So I have my experience there. So that's why, I am, bent towards designing and creating or developing financial applications. So, having said that, the name of the application is Web API. So let's go ahead and create the project. So we are going to look at the components, some of the things that we'll see here. And if we look at, we have like a default built project here, which is weather forecast. So let's see, here we have the weather forecast entity. I wouldn't even call it an entity. This is not an entity because it's not mapped to any storage or DB. So this is just like a model. And what this model does is like it maps the response, the response field that will be sent back. So it's just acting like a DTU here. That's what this weather forecast is doing. So it's not an entity. Sorry to use that word. This is not an entity. It's just a model class that's acting like a DTU for the response field and all of that. So here we'll see the wallet um, API, and there is something here in this controller. Yes, here is the controller class. And if we look at something here, we would see that here it has an HTTP action or method, which is HTTP get. So here is just getting information from the server. So, but let me quickly run this and I'll come back to explaining these components better. Here, automatically, um, ASP.NET makes use of what we call um, Swagger. So Swagger is a tool that helps us to test our API and also read open API documents. And this helps us a lot to test our API for security issues, for clarity, in case there's any error, because we don't want any error to get out into production. So Swagger is a tool. We can also use Postman to do that, but Swagger is a tool. I think it's also inbuilt into this automatically. Though we can change it. We can use Postman just like I said, but it's okay to use Swagger as well. It helps us to test APIs. As we know, this is not a console program where we'll have maybe run and we'll be able to run the program and exit. So Web API, once the system starts, it stays on standby and waits for, user request, HTTP request, processes the request, send back response, go back and on standby, waiting for another request to come in. So that's how Web API works. So now here we'll see weather forecast / weather forecast. And let's just do something here. So before I go back to, we are trying to see what, when we execute, this is what our response should look like. Yeah, I forgot to say something. For every HTTP request, it's like, it looks like an envelope. There is an header and there's a body. So an HTTP request, it looks like an envelope that on the outside you have a label like an header address, the address of whoever the letter is going to, but the body of the letter remains hidden inside the envelope unless it is being opened. And ideally, it is not supposed to be opened by anyone except the person for whom the letter is meant. So if you've ever had a letter posted to you, you'll know that on the outer part of the envelope, there's always an address, which is the header stating where the letter is going. And no one opens that letter until it gets to you, and you are the right person that can open the letter because you are the recipient, just like the server. So you open it. And in the same way, we have it here. This is something I think I've probably worked on before. But here, let's click on execute and let's see what you can see. This is our temperature. So this is the response header and this is the body. So here you see the response header. You can see Kestrel here, which is the inbuilt server for ASP.NET Core. So here is the body, response body and response headers. So this is what is on the body of your the outer part of the envelope, and this is the letter inside the envelope, which is the response body. I hope that's clear. So having showed us this, we can see we use this to test the HTTP GET method. But here you can see the weather forecast. One thing that HTTP also, oh yeah, there's something I also did not mention. Here we are dealing with REST API. REST API. And REST API. There's something I'm trying to remember. Yes, that's representational state transfer API. And this API is an API that is stateless. It makes use of nouns, not verb. For instance, instead of doing something like this is REST, or you can say RESTful, but let's say REST API. So it is stateless. I will explain what stateless mean in this context. So another thing here, it is stateless. There's something else that is peculiar to it. Uh, okay, I will speak better on it as we go on. What does stateless mean? Stateless means that an HTTP request is complete in itself. It has all the information needed for the server to successfully operate on it. It has all the information needed by the server. So a REST API is stateless because it does not retain the what will I call it now? It does not retain the session state of how I'm trying to look for the best word to use. But primarily what it means is that every request is complete in itself. It has all the information that is required and needed for the server to work on it, or for the server to operate on it. So it means that it does not retain session state between requests. It does not retain or keep session state record between requests, except if one implements something like called maybe cache um, session. One could also implement maybe the use of token and so on and so forth, just to be able to, have for the system to retain the session state between requests. So having said this, let's quickly go back to the project we've opened now. Let me stop this. So let's look at this one after the other. We have the program.cs. So program.cs, this is like the composition root. This is where the object graph is created. So here we have the variable builder, which helps us to, initiate a DI container. It registers the services. As we can see builder.service.add controllers. So what this does, it helps us to register all the controllers in this project through the dependency injection container. Here we can also see builder.service.endpoints API Explorer. You can see the Swagger gen, which is the Swagger tool dependency being, registered here as well. Then it builds the dependency injection container here. And here we can also see app.useSwagger, which is the tool I spoke about, then using the Swagger UI, which is the UI we saw when I ran the program just to help us test our APIs. Then we can see use HTTPS redirection. These are the middlewares I spoke about the other time. Then we have use authorization. Then we have map controllers. So what this map controllers does is that it scans for the controller class and maps the routes to the endpoint pipeline. So it maps the route to the endpoint pipeline. And here, if we look at the weather forecast controller, you can see that when we ran the code, we are getting something like this. Like weather forecast. But if we come to this code here, you will see here we have weather forecast controller. So automatically weather forecast controller becomes weather forecast because of this attribute here. So this attribute is making us know that, okay, this is the controller for this. So it maps the HTTP request method to the controller action. And since our HTTP request method is the get weather forecast, as you can see here, get weather forecast. This is the HTTP get, and we see weather forecast. So what it does is it maps the HTTP request to this class action of the HTTP get, and then it returns the response to the client. So let's quickly do something. There's an example I want to run here. Let's delete this. This video is becoming longer, which I actually don't want. But I hope I can quickly do this. I hope I can quickly do this. So here I want to add a new folder and name it model. So inside this model, I want to add a new item. So let me call it wallets. So what I actually want to do is I just want to do like a model. So here I'm saying public GUID ID. I'm saying public decimal balance. So this is just what I want to do for this. Then in the controller, don't forget we don't have we're not dealing with any, let me say, wallet controller. This is the wallet controller class, and the wallet controller class, don't forget we have to use API controller and this. So here, don't forget I want to use something like controller base, and MVC controller base. No, that's not what I'm trying to use. It's not supposed to generate. What's going on? So here I'm doing, because we don't have a database, I just want to quickly show us some things here. So private, I'm using static read only, because normally every HTTP request is a new request. But because so that we can have a quick understanding of what we're trying to do. So this is the shortcuts for lists. list of sorry, list wallets. I didn't give it in wallet equals this. So yeah. So now one thing I want to do is here I'm saying HTTP gets, not HTTP posts. TP gets. So I want to say, in fact, it's just there already. So I'm not supposed to do this, but because of our time, then HTTP post. So for the HTTP posts, I want to say exactly this is what I need, but I don't want to use this. I just want to say created, then say wallet. The created results for the response. No value to method create takes one argument. Okay. So overload. Method. Should I say wallet.id, comma wallet dot balance? Does that work? Okay, this has to be string. Then maybe I just do okay for now. I don't want to waste our time. So let's see how this will work. Just to quickly do this and then wrap up this video. Thank you for your patience. I just want to quickly wrap this up so that we can see how this works. Now we can see we've got here, we have, looking at this code, we have two HTTP methods here. We have HTTP get, HTTP posts. So if you come back to this place, we will see, let's post first. Let's try the posts. So this is what it's supposed to look like. So let's execute and let's see. As you can see, response body, response header. This is the code 200 and the description of the code is okay. So don't forget that. Then let's do 3 more. So now we have 3. We have executed this 3 times. So now we want to get all the records in the list. Don't forget there's a reason why I use static so that it can retain all the resource we have created, can retain the wallet we've created, because if I do not put this static, we are not going to have that. It's going to be returning the list back to default because it sees every HTTP request as a new request. Remember I said REST APIs are stateless. So that's why I put this as static. So now let's go back and take a look at our gets and see if we have all that. As you can see, we created 3 wallets and This is the list here. So it shows that we were able to persist it by using static. So this is the first wallet, second wallet, third wallet. I hope we understand that. Don't forget I said Swagger is a tool that helps us to test, our API endpoints, and it also helps to ensure security, clarity. It protects us against any form of, vulnerability, helping us to see whatever issues it is before you know, um, our project or system gets into the production environment. So that being said, this brings us to the end of today's video. Thank you for joining. Thank you for your patience. Kindly comment in the comment section what you think, your thoughts, your observations, any questions you have. If you want me to do a video on any particular thing to, bring more clarity, please just put that in the comment box. Click on the like button so that I can get to wider reach, and subscribe for you to get updates on my new videos as I, drop and upload new videos. Thank you guys. See you in my next video. Bye.